To understand where software is heading, we have to look at how we have built it for the past decade. Traditional automation operates exactly like a heavy cargo train. It moves fast, but it is locked onto perfectly straight, rigid steel tracks. We write linear scripts based on strict deterministic logic. If X happens, execute Y. This rules-based execution is highly efficient for repetitive tasks in controlled environments. The problem is that deterministic approaches are brittle. The moment a user interface changes or an unexpected data anomaly occurs, the execution chain snaps. The script cannot adapt to the anomaly, it simply crashes. That limitation forces a transition from standard automation to autonomous AI agents. Consider a rugged, multi-wheeled rover autonomously navigating shifting, unpredictable rocky terrain. Unlike the train on fixed tracks, an agent acts like this rover. It operates non-deterministically, constantly assessing unmapped environments and changing direction to avoid obstacles. To survive in modern, dynamic software environments, we have to abandon rigid pipelines and build self-correcting systems. Agents possess a capability that standard scripts lack entirely: a central reasoning engine powered by a large language model. Instead of mindlessly executing pre-compiled lines of code, an agent actively interprets human intent. A traditional linear logic tree shatters at a failure point, transforming into a continuous feedback loop. The agent dynamically formulates a plan. Upon encountering a failure, it analyzes the block, generates an alternative path, and reroutes around the obstacle. Software no longer stops at an error. It actively reasons through it. Building this level of autonomy requires a specific architecture composed of three interacting pillars. The brain acts as the central processor, decomposing complex goals into actionable tasks. These are informed by memory, drawing on short-term session data and long-term vector databases. Finally, context passes to execution, connecting via APIs to physically perform the work. An autonomous agent is the continuous orchestration of reasoning, historical context, and direct environmental execution. Let's observe how this architecture performs during a high-speed sprint. Consider a quality engineering and automation agent, tasked with testing a complex e-commerce browser extension. The agent receives a prompt: ensure the review ranking algorithm displays accurately on the latest build. The agent initializes and autonomously opens a headless browser to begin the test sequence. It navigates the interface, injecting test data directly into the system to evaluate the ranking algorithm. Then it hits a critical failure state. The ranking user interface fails to load because a specific CSS class was altered. A traditional script crashes here and outputs a standard error log. The agent pauses, activating its fission capabilities to parse the document object model of the page. Analyzing the DOM, it accurately identifies the exact broken CSS selector causing the visual failure. As shown in this GitHub mockup, the agent generates a detailed bug report and drafts a pull request for the precise code fix. The system detects the visual failure, independently engineers a functional solution, and submits the corrected code. We see a similar application in financial technology. In finance, data is abundant, but synthesizing unstructured data manually is a massive operational bottleneck. We can deploy a Fintech agent designed for long-term portfolio strategies. Its objective is to track NIFTY 50 blue-chip companies, specifically stalwarts like Tata Consultancy Services. Every morning at 8 a.m., it initializes web search tools to aggregate incoming earnings reports. It executes deep-dive data extractions, calculating historical price-to-earnings ratios. Rather than providing a basic summary of the news, the agent synthesizes this raw information, cross-referencing incoming metrics against established long-term investing principles stored in its memory. This animation illustrates how the agent filters the daily market noise. A massive funnel ingests dozens of raw documents. A strict threshold line blocks irrelevant data, allowing the agent to actively isolate true fundamental shifts in a company's business model. When a predefined risk or opportunity threshold is met, it generates a comprehensive insight report, immediately alerting the portfolio manager to the specific shift. The agent operates as a ruthless filter, converting overwhelming data velocity into precise, threshold-triggered intelligence. Individual agents operating in isolation are effective, but the terminal state of this technology relies on multi-agent systems. We can see how this convergence works by linking our previous examples. The Fintech agent completes its NIFTY 50 market insight report. Instead of sending that report to a human, the Fintech agent transmits its synthesized data directly to the QEA agent. The QEA agent takes over the loop. It autonomously tests the payload and verifies that the complex formatting of the new financial insights renders correctly on the target web platform. This network map shows the handoff. The Fintech agent sends its data packet to the QEA agent. Once verified, the QEA agent pushes the final report out to the live web platform entirely on its own. Throughout this entire pipeline, from data aggregation and synthesis to testing, verification, and live deployment, there is a total absence of human intervention. Software is evolving from a static support tool requiring constant direction into collaborative, autonomous networks that independently create, test, and deploy solutions on our behalf.